And let me know if you don't see what's on my screen. You should be able to see what's on there. Now, let me go ahead and turn on my handy dandy document cam and we'll discuss some things. Well, that can be in the background. I finally got everything installed on my computer. Yay me. Okay, you're not going to talk to me. I think it's just.
What do you want me to say?
I mean, say congratulations or something, say something to make me feel better about myself.
Good job. It took you to
the
semester.
I appreciate
Yay.
it. Yay, there you go. All right, now, some of you may have noticed some things that happened on the test and homework page, maybe. Hopefully you've seen some things changing there.
All dates are the 22nd.
Let me tell y'all something. If I give you a test back and I accidentally gave everybody 10 points, are you going to raise your hand and say, Mr. McClure, you gave us an extra 10 points. Do you want to take them off or what? If a teacher gives you something, what are you going to do?
Keep your mouth shut.
Keep quiet.
Okay, one person said keep your mouth shut. What did the other person say?
I usually try and keep quiet.
Okay, so if I give you something on, say, like test and homework, and it looks too good to be true, are you going to write me an email that says, I'm confused? Are you going to send me an email that say are you going to take advantage of what I give you?
I mean, that's a complicated question.
Oh, well, I've already got 2 emails from this class.
You're trying to get us in trouble, but I mean, I will take full advantage of you.
Exactly. All right. If I give you something and you're looking at the test and homework and you say, golly, what did he do? What? You should take advantage of it. You don't email me and say, I'm confused. Oh, Miss Sterling has had me before, so she knows what I'm talking about. But
I really don't.
Emails?
Oh, you don't? Okay, well, you haven't seen the homework or the test then.
Yes, I have.
You didn't notice the dates?
I did notice the dates.
That's not 10 points. The dates aren't 10 points.
Okay. All right.
I gotta go look at the homework now.
I had students tell me they were confused, so I don't know why they're confused. Anyway, you have until the last day of class, which is on Wednesday. That's going to be the 22nd, to finish all homework and anything else that I've opened up for those times to give you a chance to do what? Improve your grade or catch up on work that you haven't what?
Done.
So don't send me an email that say you're confused. All right. Final exam and the last test. Last test is already up. The last test will cover Chapter 5, those sections that I gave you that are important. And I don't know if you can see the percentages on your homework, but if you do, I took off 5.1 through 5.2. I made that like 1% of your homework grade. You're welcome. Chapter 5, I'm going to put 5.3, 5.4, 5.5, Hubert's homework. And did you notice that I also put the Chapter 2 homework that I told you I was going to put, and the Chapter 6 homework that I told you I was going to put?
Yeah, all that's up there, plus the test.
Okay, last test starts on 7/22. Well, it's already started.
I was gonna say we could take it now.
Yeah, and it ends midnight on the 27th. So does your final exam. Final exam We'll start on the 22nd or 23rd, somewhere in there. 22nd, 23rd, and go until the 27th. Let me reiterate. Let me change this resolution. I got to get this fixed. Damn Russians. There. Okay, I don't forget what I was saying, but cut off on the 27th. You have 2 attempts. For those of you that, you know, lightning strikes on everything you do. You have, I haven't even made it out yet, but probably, I would say probably 20 to 25 questions. The reason I'm making it short is because it is calculus and it is, you know, time consuming. You have 2 hours and you have 1 week to take the test. Okay. So therefore, everybody should, this is the 3rd or 4th time I've covered this, but I'll still have somebody email me by the end of this week. Anybody want to bid me? Okay. All righty. Now, I did not have this hooked up the other day because I called IT and I wasn't able to do it. And physics professor is given 3 attempts. Oh, okay. So you're trying to, I see what you're trying to do. Well, I'm sorry. You get 2 attempts. Lord, there's some people in the math department would have a fit if I gave 3 attempts on the final exam. Oh my God, I'd have one person melt down.
Professor is slacking so hard. I think he feels guilty. So.
Oh, is that what it is? Okay.
Yeah, it's bad. It's real bad.
Okay. Now we started. I'm trying to see if I got anything else to cover. Oh, this I was telling y'all what happened. Anyway, I wasn't able to get this done, but we do have the calculus in motion now on my computer, so now you can see it, and it's not running like so now it's running really fast because I got a souped up computer and I feel good about myself. But as you can see, this is the area between 2 curves, and this is exactly what you're doing with the red hairline rectangle. You're taking the difference between the 2. Now somebody remind me, how many examples did we cover last Thursday or Wednesday or whenever Thursday? Was it Thursday?
Several.
How many exactly?
I don't remember exactly
I
off the
think it
top of
was
my
like
head.
5.
5. Okay, we got a few more to go over, and I'm going to cover some that are a little bit different. And then we'll go and look at disc and washers. And I'm going to cover disc and washers tomorrow and Wednesday. So I'm going to let you look at disc and washers so you can see where it's coming from there. And that's going to be volume, should be volume, or yeah, should be volume. Volumes by revolution. And this is pretty simple, but this is where you see you've got a gap between either on the x-axis or the y-axis. When you have a gap, it's called a what? It's called a washer. When you have no gap, and I can't remember how to do it, but you should be able to move this. When you have no gap, it's called a what? A disc. Now, we're going to be doing this around the X and Y axis, but this is basically what you're doing. This is a disc, and this is a washer. If you have a gap, it's called a washer. If you don't have a gap, it's called a disc. And this is volume. So I'm just going to show you a couple of these, and you can, oops, sorry. You start over. Well, let me reset it. Sorry. There. Okay, revolve one rectangle. One rectangle. I don't want to do one rectangle. There we go. It's supposed to.
Priority one
Oh, well.
message coming in on secured channel.
That's what you're going to do when you first start off. But then, of course, you make these discs. You make them basically, or these washers. You make them thin as a what? A hair. And if you make them thin as a hair, the error here and here and here gets smaller and smaller and smaller. There's a couple of these that I wanted to show because, let's see all shells. There we go. There's, I used to call this one the Colosseum because it looked like the Colosseum of Rome when I studied it. But you're talking about here is a hyperbolic function or the square root function, and you want to find the volume as it revolves around the y-axis, or it moves it. You can move it back and forth. You can move it back. Well, it won't let you, but anyway, you can move it back to the x-axis. That's what I was trying to do. There we go. Put it on the x-axis, and you see that you're finding the volume under this curve all the way around. Now, the reason I'm showing you these, not that you have to master them in 2 days. That's not what I'm showing you for. I'm showing you because I want you to be able to visualize volume versus area. And you can see these right here. Sorry. There is a washer. This one is revolving around the x-axis. And I gave you a file today. And if you look on the page, it is on there. It's the formula for volume of a disc in a shell. And you'll see that. And like I say, we'll cover it tomorrow, but I wanted to move this up. There we go. And this is no gap. And you see now you got a disc. And there's the hairline disc. And that disc is going to move from the left side to the right side. Just like that. There it goes. That's exactly what you're doing with the antiderivative. And remember, that disc right there is, I don't know how thin you could think of a hair, but that disc is as thin or less than a width of a hair. And that's what you're doing when you're finding the volume. Again, you got a disc. If you want to make it different, if you want to have a space in there, now you got a washer. And there's your washer. Now, I'm going to tell you something. Y'all ought to be very thankful that you have computer graphics nowadays that show you this. Because I'm not saying anything, but I am, old, and I didn't have this. And let me tell you, the wolfram, you can actually rotate the wolfram, and you can actually see it from different views. This is actually ancient, but I like it because you can actually see it, and you hit the sweep. You can actually see what you're doing with the antiderivative from 0, from 2 to 4, or from 5 to 50, or whatever the case may be. So again, just little things that kind of show you the difference between, area and volume. Here is your disc going around the y-axis. And it just continues to go around the y-axis. Here's where you have a figure, like a sine wave, and that's where you get your actual shapes. Now you could actually take this into a mechanical type situation right there. And there's your washer. But again, if you take if it'll let me, take it back to the x-axis, you don't have a washer anymore. Now you got more of a disc. And sweep. So hopefully some of y'all, that'll help you with the visualization between a disc and a washer. And we'll go over more of that tomorrow. Oh, I've got to show you this one. Revolve. That's your bowl. And then, of course, you're going up the y-axis. There's your washer. And I'm going to tell you something. When I was a student in calculus and we didn't have these 3D drawings, I had no earthly idea what they were talking about, a disc and a washer. I could not figure out what they were trying to draw it on the board, and it just didn't work. So hopefully some of y'all can actually see the difference between a disc and a washer now. And of course, some of y'all know probably invented it, but I'm not here to show the people that invented it. I'm here to show the people that don't, never seen it before. And there's your disc. Well, this disc down here, but then it opens up because you got a curve right here, so it does open up. Okay, so that gives you a little bit of visualization. What?
And would that be a disc and a washer?
Yeah, a disc and a washer. It starts off with a disc, but it opens up down here at the vertex, and then it opens up. And I hope that kind of helps some of y'all. I mean, I don't know if it does or not, but let me get out of that. And let's get back to area between two curves, and that finish up today. I'll give y'all 2 days of being area between two curves. So let's go ahead and finish up. All right, here's one. Let's go with f of x. I'll do f of x in purple. X squared plus 1. And g of x, I'll do in pink. X. And in a minute, I'm going to use my whiteboard. I'm going to try to use it and see if it'll work. Okay. So go ahead. What's the first thing we do? We already talked about this. What's the first thing we do? Sketch the graph, Hubert. That's right, class. Thank you. Thank you for your interaction. I appreciate that. I'll just be in one of those moods today, huh? Is that it? Is it just end of the semester and y'all just do not want to talk?
Listening.
Oh, you're listening. Okay. Well, I appreciate y'all being so attentive. So here is, of course, I'm going to assume that it's in the first quadrant because we want to try to stay in the first quadrant with some of these. Now this one may be a little bit different because, and we're going to go from 0 to 1. Okay, this one I'm telling you to go from 0 to 1. And I'm going to draw, and a lot of you are going to say, well, wait a minute, I'm confused. Well, we got a y-intercept of 1 right here. So we know that that function is going like this. You know your parent graphs. And then this function, okay, that's supposed to be in purple, sorry. You won't be able to tell the difference, but there we go. That's purple. And the pink is going through here. I even went and bought a ruler for y'all. Y'all know the semester's about over.
Yeah, and you're finally getting it all together.
Yeah, I know. I got everything together. I got my new equipment, and they're going to send me back to AC 137. I told them I'd be very happy if I just stay here. I think I need to stay at home. I don't want to catch Rona. I'm so scared.
I think you should stay home too, and then let you teach calc too.
No, well, evidently I'm not good enough to teach Cal. You got to teach it at the the Pendleton campus.
Yeah, but if you're at home, then
Yeah, that's true. Don't even get me started on that.
I've just heard too many horror stories.
I know.
And
You
other
want me to
professors.
teach? You want me to teach Calc too? I know.
I'm gonna keep begging.
All right, there you go. Sometimes your curves aren't going to what?
Intersect.
They're not going to intersect. So what do? You just say, oh, well, they're not going to intersect, so I quit. No, that's not what you do. So I'm going to take my handy dandy. I never use this blue highlighter because I don't like blue highlighter. Looks like a snow cone. Anyway, there is the area that we want. Now, of course, tomorrow and the next day, we're going to revolve that sucker around the x-axis or the y-axis and it'd be a V-shaped bowl if it was going around the x-axis. If it was going around the y-axis, it looked like a bowl with a V bottom. So there's the area we want. So all we need to do now is take the antiderivative of the first one. Now, can you do it algebraically first and then take the antiderivative? Yes or no? Yes, you can. So there's two ways to do it. One, you can say, okay, well, I'm just going to subtract the two. X squared plus 1 minus x. And that's going to give me x squared minus x plus 1. And then take the antiderivative. Or you can say the antiderivative from 0 to 1 of x squared plus 1 dx minus antiderivative from 0 to 1 of x dx. Does it matter what you do? No. But I do want y'all to do it now. Go ahead and do it.
So you always subtract them from each other.
Yeah, you always do. Remember? I told you that. And if you look, I'm going to show you on the file. Hold on, I'm bringing in Teams here so you can see what I'm doing. There's your file. I don't know, y'all probably didn't have time, but there it is. See the area volume file right there? That is this file right here. And what is the area between curves? What do you do, Miss Hart? Top minus the what? Bottom. F of x minus g of x.
Because if you do it the other way, it'll still work out.
It'll give you a negative, but what are you supposed to say to yourself if you get a negative area?
You can't have a negative area.
Exactly. That's
Scalar, not a vector.
That's like saying negative 200 miles to Atlanta. There's no negative and positive signs on mile markers on I-85. There's no such thing as negative area. So you always subtract. And in this case, I'm going to go over here, and that's going to give me x to the third over 3 minus x squared over 2 plus x evaluated at 0 and 1. Well, I'm going to do 0 for y'all. There, I just did it in my head. And what happens to 0? It cancels out, Hubert. That's right, class. So I can put an X through it. And now I'm going to plug in 1. 1/3 minus 1/2 plus 6/6. And this is going to be 2/6 minus 3/6 plus 6/6. And negative, that'd be -1 and 5/6. Y'all check me. 5/6 square units. So this area right here is somebody, what is 5/6? Somebody do it in your calculator. 0.8 something. What is it?
I don't know. My phone's dead. I don't have a calculator. My phone's dead.
0.8333.
0.833 repeating square what? Square units. Now, the reason I wanted to show you this question was because sometimes the lines do not intersect. And usually, if they don't intersect, the parameters will be what? The parameters will be given. So I'm going to highlight that in pink. That means you need to write that down and put a note. If they don't intersect, then
Priority 1
it will
message
be
coming
given.
in on secured channel.
Okay. Test question. And a lot of you are saying, well, Hubert, you're giving us an awful lot with 0. Well, you're welcome. And this is Calc 1. Okay. I'm not asking you to design O-rings for the space shuttle in Calc 1. All right. It's an introductory. This is the first calculus. You got to learn the basics. And learning the basics does not mean do on a scale from 1 to 10, do a 10 your first semester. No, that's not what you don't. So I conflict with a lot of my colleagues on that. They believe you need to be able to design the space shuttle by the time you get out of first variable calculus, and you don't. So here's a nerd. How about y, and we've done one like this. How about y is equal to x squared? And I'll do this in green, verde. Y, or g, or, g of x, or y sub 2, is equal to 2x minus x squared. Okay, while I'm drawing it, you graph it. Dadgum, I keep forgetting to use the colors. There's the orange. And the green is going to look something like this. Of course, it's not going to be perfect, but I exaggerated a little bit to make this area bigger. So this one intersects. So we're going to find out where they intersect. Of course, one of them is 0. So whenever we want to find out where they intersect, x squared is equal to 2x minus x squared. Set them equal to each other. I'm going to bring that x squared over. And that minus, they'll bring the 2x over. And that's going to give me 2x squared minus 2x is equal to 0. Factor out of 2x. And that's going to give me 2x is equal to 0. And x minus 1 is equal to 0. So our two intersection points are 0 and 1. So this point right here is 1. All right, now set up your antiderivative. And I'm going to get my whiteboard set up. Kate, you still in here?
Yeah,
I
we're here.
am. Yes.
Okay.
So long as you are.
And that's on. Oh my, I've got to figure out a way to keep this scanner from moving. I think my kitty cats have something to do with it. I think my kitty cats think that the scanner is a mouse, and I think they hit it with their paws every now and then. Show you a trick I learned in the war. I think I can actually do this. Let's see if I can do it. Use my transparency. I should be able to write on my document now. So that's going to give me antiderivative from 0 to 1 of, I'm going to take the upper one, which is the green, and that's going to be negative, and I can use green limited on my, let's see, green. Yeah, I do have a green. I can use that green. And that's going to be negative x squared. Ooh, that's set on highlighter. Give me a second. There we go. I had it set on highlighter. Negative 2 x squared minus x to the third, x squared minus x squared. I'm sorry, negative 2x. I messed up, sorry. Give me a second, guys, I'm sorry. I gotta hit the, not let me erase it. There we go. I'm just going back to the black. sorry. So antiderivative from 0 to 1 of 2x minus x squared, 2x minus x squared minus x squared dx. And that's going to give me the x squared, negative x squared minus x squared is negative 2x squared. So that's going to be antiderivative from 0 to 1 of 2x minus 2x squared dx. Now we're going to go to the whiteboard after this, so that way I can do the whole thing. I'm just writing on top of my Word document there. So let's go to my whiteboard. And antiderivative 0 to 1 of 2x minus 2x squared okay, I hit my button, sorry. Go away. Why is this acting like this today? Oh, I hit the sensor. Sorry. One thing about having a stylus is sometimes I hit the button that's on the stylus. Okay, minus 2x dx. And that's going to give us 2x squared over 2 minus 2x to the third over 3. 2x to the third over 3, evaluated at 0 and 1. And that's going to simplify and give us x squared minus 2/3 x to the third, evaluated at 0 and 1. Now, the 0 is going to cancel out. So the 0 is going to cancel out. So you can just draw x to the 0. And that's going to leave us with 1 minus 2/3. So 1 minus 2/3, which is 3/3, minus 1/3, sorry, 2/3, which is 1/3 squared units. Any questions on that one?
No.
Nope.
Okay. Got another one here. Let's go with, put a graph on this one. And I'm going to take my handy dandy straight line maker. And this is in the first quadrant, so I'm going to kind of make it big. And that's not what I want. Would help if you tried to, help me out just a little bit. I'd appreciate it. There. That don't, oh, it's translucent. There we go. And I'm gonna make it a little bit smaller. And let's go with there's our graph, and I'm going to go with, here's your two functions. We got f of x is equal to 3x plus 5. F of x is equal to 3x squared plus 5. And g of x, we'll do g of x in a orange. G of x is equal to negative x plus 3. So negative x plus 3, here's your, it's going to be 1, oh, come on. 1, 2, 3. So we got a point right there. And let me draw a orange line going in a negative direction. Orange line in a negative direction, 45-degree angle. Close enough for government work. There's that line. And then a parabola with a y-intercept of 5. So let's use our green. So that's 4, 5. So there's the y-intercept there. Let me use my handy-dandy green marker. So we've got a parabola going up like that. Again, it is not, so that means that it's not intersecting, so that means somebody's got to give us some coordinates. I meant some parameters. So 0 to 2. All right, I'm going to start the timer. And I'm going to give y'all, while I'm finishing up the drawing, I'm going to give y'all a couple of minutes to get started on it. Anything to discourage you. I figure a couple of minutes will discourage you, right?
You got to try a little harder than that.
Oh, I hear you. I like to hear that. All right. So let me draw. I'm going to shut up while y'all work. Really? I'm going to have to get me I'm going to have to get something to put on the stylus so I won't hit the button on it and make it do crazy stuff. Okay, well, I had to erase my line a little bit, but y'all see the gist of it. All right, I'll give y'all another 30 seconds. That'll be 3 minutes. Now, could you do the algebra before you did the calculus? Could you do that? Yes. You could say 3x squared plus x plus 2. You could do that. Or you could set it up and do it in the antiderivative symbol. However you want to do it. All right, that's 3 minutes, 15 seconds. All right, so here we go. I'm going to do the algebra first. I'm going to take 3x squared plus 5 minus parentheses negative x plus 3. And I'm just going to do the algebra. I'm just going to subtract them, and then I'm going to put them in the antiderivative. Excuse me, Rona. 3x squared plus 5 plus x minus 3. And that's going to give me 3x squared. I'm sorry, what? Did somebody say
Minus
something?
3 or 2?
I ain't finished yet. Hold on. I'm
Oh,
getting there.
I see now. Okay.
Yeah. Can I be in charge for a while? I appreciate it. 3x squared plus x. And as Miss Hart said, plus what? 2. You're tough, Miss Hart. You can take it. All right. So now I can set up my handy-dandy antiderivative from 0 to what? 2? And we can cancel out the 0.
Priority 1 message
So we can
coming
take
in
the
on secure
handy-dandy
channel.
red pen, and we can cancel that guy out. So now we're just going to take the antiderivative and the antiderivative of 3x squared, I'm going to write real small, 3x to the third over 3 plus x squared over 2 plus 2x evaluated at 0 and 2. And as we said, the 0 is going to go out. Yeah. And of course, that means you know how to do this. So I'm going to put 3 dots. Dr. Harden's 3 dots. You know how to do this. And I come up with an area of 14 square units. But y'all need to check my math. 14 square units. Yes, no, maybe. Any questions on that one? All right, I'm going to let y'all do this one on your own, and it's a little bit different. So that means that most of you are going to what when you see it? Okay. Thank you for your input. Thanks a lot. Most of you probably quit when you see this one. And we'll do, since I got one colored turquoise, let's go with orange, Miami Dolphins. Orange and turquoise, Miami Dolphins. And that didn't even get a nothing from y'all. F of x is equal to the square root of negative x plus 1. Well, I tell you what, let's go and start from the beginning. X is equal to 1 minus y squared. And turquoise I got to turn that off and bring this down. There we go. And that's going to give me x is equal to y squared minus 1. Now, what's going to make you stare at it for 15 minutes? Somebody tell me. Why are you going to sit there and stare at it for 15 minutes instead of do the problem?
How do you know I'm not doing the problem? I'm sitting here doing the problem.
I'm just saying some people stare at it for 15 minutes.
How would you possibly know that, though?
Because I've been teaching for a long, long, long time.
That doesn't say anything about what any of us are doing right now.
I'm not saying y'all, I'm saying most students. Okay, so the people that are not doing anything, why are you not doing anything? Can somebody tell me why?
They can't handle the fact that it's switched.
Exactly.
Wise.
The variables are switched. Exactly. In other words, you should look at that and go, It should be like a thorn in your side. So what happens if you can? What do you do? What do you do to get by this predicament?
Change variables because they're just variables.
Exactly. Solve for what?
I mean,
Solve
for this,
for what?
you're solving for x or whatever, but you just swap
Not
it.
solve it for x. It's already solved for x. You're going to solve it for
Or
what?
For y? Does it matter?
Solve it. Yes, solve it for y. In algebra, what 90% of the time when you're graphing something, what variable is solved for? Y. So when you see this y right here, and it's not solved for y, that should be like a thorn in your side. You should solve for y. So that's what we're going to do, solve for y. So that's going to be x minus 1 is equal to y squared.
Priority 1 message coming in on
And the
secure
square
channel.
root of y squared, take the square root of both sides, so y is equal to the square root of x minus 1. Now you graph that. Now we solve the other one. And my purpose for showing you this problem is on a standardized test or something like that, they love to do this. They love to set x equal to something, and the students sometimes just sit there and stare at it for 15 minutes. So x minus 1 is equal to y squared. Y is equal to the square root of x minus 1. Okay, now you can graph, what I'm supposed to be, 1 plus 1. I thought. What I'm supposed to be plus 1. Okay, there it is, 1 plus 1.
Turquoise one.
Thank you, Mr. O'Quinn, Mr. Quiet today. Why are you so quiet, Mr. Quinn?
At my house.
Okay, that's all right.
I'd like to know why the rest of the class is quiet and only me, O'Quinn, and Sterling talk.
Because that is the way that's the way classes are. You got 10% that are winners, and you got 10% that are losers, and the rest of them just stay quiet. So we got to draw these two guys. And they're basically going to look, I'm going to do them in black. Well, let's see. plus 1. That's going to be a shift to the left. So that's going to be this one. Let me draw 2 black. And my turquoise looks like this. And my orange looks like this. And since the calibration's a little bit off, they cross. I'll go ahead, if you set them equal to each other, and I'm going to do that over here. So set these two equal to each other, you're going to get -1 to 1. -1 to 1. That's where they intersect. And you can do that on your calculator. I'm just going to let you do this one on your calculator. So I'm going to pull up my handy dandy calculator while y'all are working. And the first one, y is equal to, the first one was what? The square root of -x plus 1. The square root. Second, square root, parentheses, -x plus 1. And close parentheses, and of course this is going to do what it always does. There it goes. Delete, 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 and delete. And the next one is the square root, parentheses, of x plus 1. And graph. That doesn't look right. Let me hit zoom. Standard. There we go. And it doesn't show on the bottom, but we're going to do the net. That's what we're doing, the net. So when we get our area set up, I'm just going to ask for the setup on this one. The setup would be area is equal to the antiderivative from -1 to -1 to 1 of 1 minus y squared, and you could take these two apart, or you could take these, either one. 1 minus y squared, 1 minus y squared minus y squared minus 1 dy. Now, the reason I didn't use the square roots is because algebraically, what would you rather deal with, the square roots or the y squareds? Algebraically, you want to deal with the y squareds. Remember, when I said solve for y, I was talking about graphing. And that's why I did this over here with these two so I could graph it. Okay, because it's kind of difficult to graph in terms of x. Now this, you're going to reduce it to a is equal to, from -1 to 1, of 1 minus y squared minus y squared plus 1 dy. And 3 dots. A is equal to the antiderivative from -1 to 1 of 2 minus 2y squared dy. Now this would be one that somebody might ask you to set up. And that would be the setup. The answer is 8/3. And that's the total area between the two, 8/3. Now, this problem could be set up as a net area also, but I did it as a total area, and that was the setup. Now, I want you to look in your notes, and I think that'll give you about close to 10 examples of area between two curves. Tell me if I'm wrong, or 8 to 10. Somebody look through your notes and tell me if that's about 8 to 10. Yes, no, maybe.
Somewhere in that range, yes.
Okay, thank you. So that's, and did somebody look at the homework for area between two curves, or how many problems are on there? Nobody remembered looking? Okay, I think there's maybe probably 4 or 5. Yeah, there's, I think, no, there's probably 6 or 8, somewhere in there. I can't remember.
There's 8.
Thank you. And that's pretty self-explanatory. Questions, gripe, complaints? Okay, y'all are just full of emotion today. Let me go ahead and shut off everything. Shut off the share and shut down the recording. And